Use the rectangles to estimate the area under the curve f of x equals x squared from x equals 0 to x equals 1. First, we sketch the graph of this parabola, which is the parabola concave upward, and we estimate the area under the curve from x equals to 0 to x equals 1 only. This is not drawn to scale. The graph is y equals x squared, and we're interested in the shaded region, this area. And again, this is not the known geometric shape, so we won't be able to use any formula. And so to approximate the area, we can divide this region into many sub-intervals. If we decide to use 2 sub-intervals, then usually in practice, we take the width 0 to 1 and divide it to 2, so each of these has a width of 0.5. And then we use either triangle or rectangles or any shape that we have a formula to. In this case, we use rectangles. Now, the question is, how do we draw the rectangles? If we use the left endpoint, then for each of the sub-interval, we would use the left endpoint to obtain the height of the rectangles. In this case, if we were to use the left endpoint, the interval 0 to 0.5 has the left endpoint of x equals 0. We then plug this 0 into the function to see how high it is, but we see that when x equals to 0, the height is 0. So we would need to draw the height of 0 only for this rectangle. What this means is that we use a rectangle with no height at all to estimate this region. And then for the second interval, if we use the left endpoint, then we would go to the graph. When x equals 0.5, the height is 0.5 squared, and then we would draw the rectangle using the left endpoints. And we already see that this will be an underestimate. Now this will be a lousy estimate, so how do we get a more accurate estimate? Well, we simply use more rectangles. In this case, using only 2 rectangles would give us a very bad estimate, so perhaps we would use 4. If we use 4 rectangles, then this time we take the length of the width, which is 1 minus 0, and we divide it by 4 to get the width of each of the rectangle. And so we take the interval 0, 1 and we cut it into 4. The endpoints are 0, and then 0.25, 0.5, 0.75, and 1. This time, if we use the left endpoints, then for the first rectangle, the height is still 0. But the height of the second rectangle is at x equals 0.25, and we use this to draw a rectangle. For the next rectangle, the height is at x equals 0.5, but remember that the height is the value of the function, so we would have to plug 0.5 into x squared. And then for the next rectangle, we would use the height of f of 7.5 or 7.5 squared. In this case, since the function is increasing, using the left endpoint would give us an underestimate. Alternatively, we can use the right endpoints. And so for the first interval, we would go to the right endpoint, go up to the graph to get the height of the rectangle. Similarly, for the second rectangle, we would go to the right endpoint and then go up to the graph to find the height of the rectangle that we will use for the approximation. For the third rectangle, again, we would use the right endpoints and then go to the function to find how high it is. That will give us the height of the rectangle, and we end up with 4 rectangles in this case because we're using 4 subintervals. When the function is increasing like this one, using the right endpoints would give us an overestimate. Usually we are very consistent. We use the left endpoint throughout or the right endpoint throughout. In some cases, you will see that we use the lowest height or the maximum height. But in theory, we will use infinitely many rectangles. We will take n go to infinity, and so it doesn't matter whether we use the left or the right endpoints. Now, for the computation, suppose we use n equals 4 with the right endpoint. Then the area of the first rectangle is the width 0.25 times the height, but the height is 0.25 squared. And then the area of the second rectangle has the width of 0.25 and the height is now 0.5 squared. And again, using the right endpoint, we obtain the x value and then plug it into the function to find how high it is. The height should be how high the function is. We need to have 4 terms if we were to use 4 rectangles. The next rectangle has a width of 0.25 and the height of 0.75 squared, and the last rectangle has the width of 0.25 and the height of 1 squared. Usually, and again, we would use either the left or the right endpoints throughout. Since the width is 0.25, we would factor out 0.25 and simply add the height. The height is 0.25 squared, and then the next one is 0.5 squared. The next one is 0.75 squared. The next one is 1 squared. And again, these heights are the value of the functions. We then put this in a calculator and approximate this, and this will give us an overestimate as we know it. Put this in a calculator. We approximate that the area is 0.46875. This is a lousy estimate because we see that there's a lot of error up here.